Welcome back to my channel. If you're new here, you're most welcome, and please don't forget to subscribe. So for today's video, we'll be looking at complex numbers. So just a small and quick recap. If we're given such like find the square root of 9, this is easy. We'll say the square root is 3. And vice versa, if we say 3 squared, this is equal to 9. Now, if I was to give you an expression where we say the square root of -9, so now this one is a bit tricky to find. If you punch it on your calculator, it will tell you math error, undefined, and all that. So, around the 17th century, a new number called an imaginary number was defined, so that a negative number would have a square root, and the letter I was chosen to represent that imaginary number. The I represents the square root of -1. So now going back to this, so if we have such an expression of square root of -9, would decompose it by saying -1 multiplying with +9, and this is basically -1 multiplying with square root of 9. So remember, the square root of -1 is I, so we'll have I, and the square root of 9 is 3, so our answer will be 3I. So from this we see that this I is our imaginary number, and we'll be using such in finding the square root of a negative number. So looking at various examples, if we have the square root of -36, so this is just basically I and the square root of 36. So this is now I and 6, which is just 6I. So for us to give another example, let's say square root of -18. So we can decompose this. So we'll have I outside because of the -1. So I, and we'll have square root of 18. Square root of 18 can be broken down into, let's break it into square root of 2 multiplying the square root of 9. The square root of 9 is 3. So our answer eventually becomes 3I and the square root of 2. So now you'd wonder why we've put the I in between. When solving questions with complex numbers, just try to be careful, because if we represented it in this format, 3 square root of 2I, sometimes the way the I is written might make your answer be wrong, because if this square root covers the I accidentally, then this is wrong. So now why putting the I in between makes your answer to be safe. Yes. So let's look at another one. Say we have square root of -23. So this is just I raised to square root of 23. We can't decompose this one, so we just maintain it that way. So now let's define what a complex number is. So a complex number is a number of the form a plus bi, where a and b are real numbers and I is equal to the square root of -1. The number a is the real part of the expression a plus bi, and the number b is the imaginary part. So I hope that is clear. So we're saying a complex number is a number of the form a plus bi. So this part is what we call the real. The number which does not have the I is what we call the real. And the number which has the I, which is b, the coefficient of I, is what we call imaginary. Let's look at some examples. Say we have negative 3 plus 5i, and then you're told to state the real part and also the imaginary part. So the real part here is the one without the I. So this part is the real part. So negative 3 is the real part. Then the imaginary part is just the number without the I. So it's just 5. So don't make the mistake of when writing the imaginary part you include the I again. That's wrong. So you just write the real number that is there and not with the I, because the fact that you've said imaginary part, it means it is the number with the imaginary number I. Another example, say we have 2 minus 6i. So here the real part, and also the imaginary part. So the real part is this number without the I, so we'll have 2. The imaginary part is negative 6. Another example, let's say I told to evaluate this number, you give the real part and you also give the imaginary part. So with this number, the real part is 5. What is the imaginary number? So the imaginary number here is 0 because we don't have the number with I. So we can just picture it that it's plus 0i, like that. In the same way, if we have maybe I told to identify the real part and the imaginary part from here. So here, the real part, and you also identify the imaginary part. So the real part is 0 because we don't have a number here, so we can imagine it being plus 0 like that. And the imaginary part is 7. So the next part that we can look at is write a complex number in standard form. So in standard form, it's putting the complex number in this state. So a plus bi. This is the standard form of a complex number. Let's have an example. Let's say we have this question. Write 7 plus square root of negative 45 in standard form. So our solution here will be that we write our expression so we need to break it down. So we need to get rid of the negative under the square root there. So that means we're having 7 plus, so the square root of negative 1 is I, so we'll have I, then we'll have square root of 45. Then the square root of 45 can be broken into two numbers that we are multiplying to get 45. So we'll have 7 plus I. So the two numbers we are having is that we're having square root of 9 multiplying with the square root of 5. 9 times 5 is 45, so we've broken it down. And the square root of 9 is 3. So that means we'll have 7 plus I, 3 square root of 5. But the proper way to write it is we write 7 plus 3i, then square root of 5. And this is in standard form. So let's just have another example for a better understanding. Let's say we are given, we need to write square root of 25 plus the square root of 9 in standard form. So for this one, the square root of 25 is 5 plus, so we need to break down the square root of 9 here. So the negative 1 is I, then we remain with the square root of 9, and this is 5 plus square root of 9 is 3, so we have 3i, and this is in standard form. We're done. Okay, so for the next part, we'll be looking at addition and subtraction of complex numbers. So we have two cases here. So we're saying if a plus bi and c plus di are complex numbers, then how do we add them? So with complex numbers, addition and subtraction follow the same rule. So that is, if we're to add these two complex numbers, we'll add the real part separately and the imaginary part separately. That is, we'll say a plus c, that's the real part, then plus we'll have the imaginary part separately. So the imaginary part is consisting of b and d. So that means we'll have b plus d, then the I will be outside. This is the imaginary part. So that's how it works. So the real part separately, the imaginary part separately. The same applies for subtraction. Subtraction also will subtract the real part and will subtract the imaginary part. So that is, I'll write it down here. So here it will be a minus c, we'll put plus, then we'll have b minus d, and we'll have the imaginary number outside. And that's how it works. So you do not go ahead subtracting the real part and the imaginary part. That doesn't work. But you know what works? It's the like button below this video. If you're enjoying it, just click the like button. Your rating really matters. Okay, let's go. So let's have an example to express what we've just gone through. Okay, so let's have this example where we're saying simplify this complex number. So here we are adding on the first one. So with our solution, we'll get the real part separately. So that is, the real part here is 7, the imaginary here is, or the real part again here is negative 2. So we'll have 7 plus negative 2. So this is one thing. Then also having the imaginary part separately. So that is negative 2 plus 4 and the I outside. So we've taken 7, which is the real, with the real number, which is negative 2. We're adding them. And we've also taken the imaginary negative 2i and 4i, we've combined them there. So now that we are here, we'll take, so now we'll add, so 7 plus negative 2. So this is subtraction. So 7 minus 2, that is 5. And then negative 2 plus 4, we'll have 2. And I outside there. So now this is 5 plus 2i, and this is already in standard form, so we leave it as it is. We'll look at the other one for subtracting. So for b, we're subtracting here, so we'll take the real part separately and also take the imaginary part separately. So that is negative 9 minus, so we'll take the real part, which is 2, and we'll cover it. Then we'll say plus. We'll take now the imaginary part, which is 4. So there is a minus here, but we'll show it. So minus 6, and then we'll have I outside there. So negative 9 minus 2 is negative 11 plus, so since negative by negative is positive, we'll have 4 plus 6, which is 10i. And this is also in standard form, so we leave it as it is. That is all about addition and subtraction of complex numbers. So the next part we'll look at is multiplication of complex numbers. So under multiplication, one thing that we should consider that will appear mostly is I squared. And I squared is equal to negative 1. Let's remember that, because remember when we said I is equal to the square root of negative 1. So if we square both sides, we'll have I squared is equal to negative 1. So always remember I squared is equal to negative 1. So quickly, if we were to just maybe do some few calculations, let's say we have 3i multiplying 5i. So multiply 3 by 5, it will give us 15. Then I multiplied with I. So remember I squared is negative 1. So this will be negative 1. Then 15 by negative 1 is negative 15. Let's have negative 6i multiplying 2i. So here if we go with the numbers, negative 6 by 2, we'll have negative 12. Then I multiplied with I, we'll have negative 1, which is just positive 12. Say for instance, we now have 4i multiplying 3 minus 2i. So 4i multiplied by 3, that is 12i. Then 4 multiplying with 2, that is 8. And I multiplied with I, this I multiplied with this I, will have a negative 1. Then we simplify this, we'll have 12i plus 8. Now writing this in standard form, we'll have 8 plus 12i. And that's our solution. But now let's say we have this kind of an expression. Let's say we have negative 6 multiplying with square root of negative 24, like that. How do we resolve it? So here, we'll first get rid of the negative 1 inside the square root. So that means we'll have I square root of 6 multiplying, then we'll get rid of the negative 1 here. So we'll have I with the square root of 24. Then we can simplify. So we'll have I multiplying with I, that is I squared. Then square root of 6 multiplied with square root of 24, we'll have the square root of 144. Square root of 144 we know is 12. And I squared is negative 1. So we'll have negative 1 multiplying with 12. And our final solution is negative 12. So it would be wrong for you to try to resolve this expression in this way, where you just say you combine negative 6 multiplied with negative 24. The solution that you get here is wrong, because you have square root of 144, which is positive 12. And this is wrong. It's not equal to what we found here. So first you get rid of the negatives under the square root, like we did. We got the I outside. Then now we simplified it. Take note. So if we want to multiply two complex numbers, we use this definition on the screen. So that is, if a plus bi and c plus di are complex numbers, then the multiplication of these two complex numbers will be that we have ac minus bd. This part will be the real, and then we'll add it or combine it with ad plus bc, which is the imaginary. So I hope we can notice the pattern that is happening. When you multiply, we are multiplying first. So we multiply A and C. This is this part. Then also multiply A with DI. So when we multiply A with D, it becomes an imaginary number. So it falls in this category. Again, when we multiply B and C, we get this other imaginary number. But when we multiply BI and DI, we get a real number, because B and D and I multiplied with I becomes I squared, which is -1. So we can try to use this format when multiplying, or just the normal expansion method that you've been using when simplifying a kind of expression like this. Let's have an example. Okay, so here we have an expression that we need to resolve. So now our multiplication, we'll use the normal expansion that we know. So we'll have 3 multiplied with 2, and that is 6. Then 3 multiplied with 5i, we'll have positive 15i. Then negative 4i with 2, we'll have negative 8i. Then negative 4i multiplied with 5i. So here you notice that negative 4 by 5 will give us a negative 20. Then I multiplied with I will give us a negative 1. So multiplying these two will give us a positive 20. Then we can simplify. We collect the like terms, the real numbers separate from the imaginary. So we have 6 plus 20, that is 26. 15i minus 8i will have plus 7i. And look at this expression, it's in standard form, so we are done. So that's basically all we need to know about multiplication of complex numbers. So the next section we're looking at is the division of complex numbers. So just a quick recap. If I was to give an expression, say 3 over square root of 2, if you look at this expression, it's not in its simplest form. For us to simplify it further, we'll multiply it with the square root of 2, square root of 2. This gives us, when you multiply the numerator, we'll have 3 square root of 2 over square root of 2 by square root of 2 will be 2. And this is now simplified. So in the same way, if I was to give you an expression of 3 over I, this is not in its simplest form. Remember that I represents square root of -1. So we can't have a square root of -1 on the denominator. So we'll multiply this expression with I over I. And giving us 3 by I, we'll have 3i. And I multiplied with I is I squared, which is just -1, which is eventually negative 3i. And it's now simplified. So another example I would like us to look at, a quick one, is, say if I gave you 3 minus 6i over 2i. So here, to resolve this, so to solve it, we'll multiply with I, both the numerator and denominator. So that is, we'll multiply with I over I, so that we get rid of the square root of -1 on the denominator. So that is, I multiplied with 3 will have 3i. I multiplied with -6i will have positive 6. So remember, I multiplied with I is -1, and -1 by -6 is positive 6. Then on the denominator we'll have 2i by I, that is just -2. So we can divide -2 throughout. We'll have -3 over 2i minus 3. Then writing it in standard form will be -3 minus 3 over 2i. And this is our solution in standard form. So another thing I would like us to recall is when solving sides, if you have 2 plus square root of 3 over 5 plus maybe 2 square root of 3, for us to resolve or solve this expression, we had to multiply it with the conjugate of the denominator. So in this case, the conjugate is we'll have 5 minus, because it's a plus here, which is 2 square root of 3 over 5 minus 2 square root of 3. That's how we get to solve it. So the same way or approach can be used when solving complex variables of such a nature. So under complex numbers, if I was to say we have a plus bi, the conjugate of this is a minus bi. So the two expressions are conjugates of each other. So if z, let's say z is our expression, let's say z is equal to a plus bi, z is a complex number. The conjugate of z will be represented as z with a bar on the top like that, signifying that this is a complex of what we've written. So this will be a minus bi. So remember that. So if an expression is given, say 2 plus 4i, and then if a bar was to be placed on top like that, so it means the conjugate of this expression, the conjugate, they're saying get the conjugate of this expression, the conjugate will be 2 minus 4i. So whenever you see a bar on top, it means get the conjugate of that expression. So let's try to consider something here. If we were to multiply a complex number by its conjugate, what is the product? So let's say 2 plus 4i, we multiply this by its conjugate. So in simplified terms, remember, whenever we have two conjugates multiplying, this is a difference of 2 squares. So we can square this part and also square this part, then we subtract the two expressions. So if we square 2, that would be 2 squared minus, we subtract them, then also square 4i, we square it. So that would be, here we have 4 minus, then if we square 4, we'll have 16. If we square the I, we'll have a negative 1. So giving us a negative 6, so we'll have 4 plus 16, giving us 20. So this entails us something. Whenever we multiply two conjugates, the product or the solution that we get is always a real number. So that is, if we are given an expression to multiply a plus bi, multiplying with a minus bi, our solution here should just be a squared plus b squared under complex numbers. So this should be in your mind. Whenever you're multiplying two conjugates, this is the final solution that you should get, a squared plus b squared. So if I was to give you an example, let's say we have 5 plus 3i, and then we have 5 minus 3i. So if we are going to get a solution here, we'll just square 5. So 5 squared plus, you also get the variable, the coefficient of the I, which is 3. So 3 squared, and that is just 25 plus 9, giving us 34. And that is our solution. Alright. So let's have an example now on division, so that you simplify this complex number. So to get our solution for this expression, we said to multiply it with the conjugate of the denominator. So that is, we'll multiply with 5 minus 2i over 5 minus 2i. Let's multiply on the numerator. So multiplying on the numerator will give us 5 by 16, that's 80. Then 16 by negative 2i, we'll have negative 32i. Then negative 11i by 5, we'll have negative 55i. Then negative 11i multiplied with negative 2i will give us a negative 22. Because 11 by 11, negative 11 by negative 2 is positive 22. But I multiplied with I will give us a negative 1. So making the 22 a negative. Then on the denominator, remember, these are conjugates. So we just square 5. 5 squared is 25. Okay, let's just show the steps so that we all get it. So we have 5 squared and we add it with the coefficient of the I, which is 2. So we have 2 squared. Simplifying the numerator, we have 80 minus 22, that is 58. Negative 32i minus 55i will give us negative 87i over, so 25 plus 4 below. Then simplifying the denominator again, we'll have 29. 25 plus 4. Then we can factor on the numerator there. We'll have what's common is 29, so that we remain with 29 into 58 is 2, minus 29 into 87 is 3, so I have 3i there, over 29. Then the 29s can divide, so that is 29 dividing, leaving us with just 2 minus 3i, and our answer is already in standard form, so we leave it there. So that's basically how you'll be doing any question on division of complex numbers. The last part for tonight's class is what we call the powers of I. So take note of the following. It shows us a pattern. If we have I raised to 1, our solution is just I. If we say I squared, our solution is negative 1. If we say I raised to 3, we can split this into I squared multiplying with I. So I squared is negative 1, so that means we just multiply negative 1 by I. Therefore, our solution is just negative I. So whenever we have I raised to 3, it's just negative I. If we say we try to solve for I raised to 4, we can split this into I squared multiplying with I squared, and we know that it's negative 1 by negative 1. The answer is just 1. So take note of this. I raised to 4 will always give us a 1. So which means if we raise it to, we try to solve for I raised to 5, we can have I raised to 4, because it's a standard that we know, multiplying with I raised to 1. So that is, I raised to 4 is 1. This one here. So it will just be 1 multiplied by I, and our answer is just I. So if we try to increase again, let's say I raised to, let's say 6. So we'll still split it into I raised to 4 and I squared. So I raised to 4 is 1. So we'll have 1 multiplying with I raised to 2 is negative 1. So our solution there is just negative 1. So this can help us in solving any exponent that we can be given when we raise I. Now take for instance, you're given an expression. So for any expression that we have, we can try to simplify it by using the I raised to 4, because I raised to 4 is 1. So if we were to try to solve an expression of I raised to 27, feel free to pause the video and try it, then you can play again so that we can solve it together. So solving it together, we can split 27. First we'll take I raised to 4. Then we have a number that we can multiply with 4 to take us closer to 27, and that is, let's say we take 6. So 4 times 6 is 24. So that means we're having I raised to 24 here. So we can multiply it with the remainder, that is I raised to 3. Because if we were to combine these now, 4 times 6 is 24. 24 plus 3 is 27, so we are going back to the origin. So I raised to 4 is something that we know. I raised to 4 is 1. So we'll have 1 raised to 6 multiplying with I raised to 3. And remember, I raised to 3 is negative 1, and 1 raised to 6 is just 1. So our solution here will just be negative I, because I raised to 3 is negative, it's this part, if you can just recall, it's this part. So it's negative I. So we need to have something that is concrete that we can follow for us to be able to solve any expression on I. So we can work with this. Say if let's say n is a positive integer. If n is a positive integer, then we can work with this kind of expression where I raised to n is equal to I raised to r. So where this r is the remainder of the division of n by 4. So division by 4. So that is, if I take back the example I gave you of I raised to 27. So we divide, first we identify our n here is 27. So if we say n divided by 4, so that is 27, if we divide it by 4, we'll have, the answer is 6, but our remainder is what? Our remainder is 3. So that means in comparison to this expression, we'll write this is equal to I. So our r is 3, so we'll say 3. And we just identify what is I raised to 3. I raised to 3 is negative I, and that is our final solution. Let's solve something with a bigger exponent. Let's say we have I raised to 153. So our n here is 153. So let's divide 153 by 4. If we divide this, so we divide 153 divided by 4, our answer here is 38, but the remainder is what? Our focus is always the remainder. The remainder is 1. So that means we'll write I raised to 1, and I raised to 1 is just I, and that is our final solution. So that's how you deal with any question that you face where an exponent is very large and you just need to express it in a simple term. Let's have another example. Let's say we have I raised to 50. Okay, 50 is straightforward. Let's have maybe I raised to 71. Yes. So first here we'll divide, since our n is 71. So if we divide 71 by 4, our focus is the remainder. What is the remainder? So 4 into 71. So 4 into 71, our focus is the remainder. The remainder is 3. So we'll write I raised to 3. And I raised to 3 is negative I. So that's how we'll be solving all expressions or questions concerning I. Thank you very much for viewing this video. See you next time.